Hello guys, welcome once more to Prepclass Physics class online, and in this video we shall be dealing with questions in electric field, and that's quite a topic that many students find difficult, and we shall be dealing with other questions that quite some students find difficult in physics, and we shall be simplifying them. My name is Jamb, and we shall be dealing with Jamb Physics 2016 question 36 to 14. Now don't forget that if you learn something from this video, click on like button. We have loads of content to send to you that will better help you to understand physics so that you can deal with Jamb. Now let's check out number 36. If the force on a charge of 0.2 coulomb in an electric field is 4 Newton, then the electric field intensity of the field is what? Now whenever you hear the word electric field intensity, you must remember the formula. There's only one formula around that, and that will become E equals this is the formula here. Anything field intensity is E equals force over charge. Although it came from force equals charge times intensity, but it is also given as E equals force over charge. It is also called electric field strength, and that's what we have here. E equals force over charge, right? Now, what's the force in the question? The force is 4 Newton. And what's the charge? 0.2 coulomb. And therefore, the field intensity is 20 Newton per coulomb. And that is the answer for electric field intensity. Now, don't forget the formula. Any question on electric field intensity follows this formula. E equals force over charge. In a later video on electric field, we will better explain all the various wings of the electric field. But the formula for electric field intensity is E equals F over Q. And if I were you, I will pen it down somewhere. It's very, very important to know that. Now let's check that. So the answer to that question is just 20 Newton per coulomb, and that's the answer. Now the point beyond which is a stretched spring, okay, does not return to its original length is called what? Do you know the answer? When you begin to stretch a spring, or you have a rubber and you begin to stretch it, the point where it will not go back to its normal shape is what? Now that means the point where if you release it, it will not form back its normal shape. Is it the breaking point, or the spring constant, or the elastic limit? Is it the elasticity point? Okay, now actually there's nothing called elasticity point. Okay, it's not a point. Okay, then there's nothing, and then that's important. Then we have this spring constant is also called the elastic constant. Now let's check this out. On the graph, on the elastic graph, when you begin to stretch this rubber or this spring, it will be stretching and stretching. That place is called the elastic region. But it will get to a point called the elastic limit, where you should stop stretching. Because I have a rubber and I start stretching. There's a point that the rubber will stop me and tell me don't go on, and that point is called the elastic limit. If I go beyond that elastic limit, the rubber is already deformed. It will become deformed. That means it will not come back to its original shape. So that means it will become a little bit oblong. It will become deformed. Okay, so that you are stretching within the elastic region. But when you get to a point, it will stop you, and that's the elastic limit. So if you force it more, you have gone beyond the elastic limit. So the rubber is now deformed. It's now deformed. So the point before it gets deformed is the elastic limit, and that's the answer to that question, the elastic limit. Now, but we have the breaking point. The breaking point is the point that if you keep stretching and stretching beyond the elastic limit, that you keep stretching that the rubber will snap or break into two, and that is the breaking point. It's also called the fracture point. The fracture point. So the breaking point is also called the fracture point, but the elastic limit is the limit where the rubber will not return to its original length, and that's the elastic limit, and that's the answer to the question, elastic limit. Let's look at number 38. Which of the following statement is applicable to a real image formed by a concave mirror? 1. It can be observed on a screen. 2. It is always inverted and in front of a mirror. 3. It only seems to exist. 4. It is formed by the actual converging of ray of light. Do you have any idea? Now look at it here. If you don't, look at it here. This is a real image. Can you see something about this? The image of the village is upside down. Now he is looking at the house from a concave mirror. That means the house will be larger than the way they are. Now look at it. Look at it now. Look at it now. What is happening to the image here? It is upside down, right? So a real image occurs where rays converge. So it is caused by convergence. That means they come together. Whereas a virtual image occurs when rays only appear to diverge. So when rays diverge or scatter, it is a virtual image. But converging image creates a real image. Now, real images can be produced by concave mirrors and converging lenses only if the object is placed farther away from the mirror or lens than the focal length, and this real image is inverted. You can see it is inverted in the picture. It is actually inverted. So the answer to that question is therefore 1, 2, 3. 1, it can be seen on a screen. You can see it on a screen. That means it in laboratory, it reflects on a screen. 2, it is always inverted, like the picture you saw before, in front of the mirror. Then 3, and then the third one, it only seems to exist. That is actually not true. Converging ray of light. So the third one is actually not true. It seems to exist means that it doesn't really exist. That's not true. The real answer to that question is not as the past question said it. It's supposed to be it is formed by the actual converging of ray of light, because we have it here that real images occur when rays converge, and that's why option 4 is correct. Option IV is also correct. It is by the converging of ray, but it only seems to exist. It's not true, because this house here really existed, so it is not true. So the right answer to that question is not as the past question said 1, 2, and 3. The right answer to the question is just 1, 2, and 4, and that means option B, the correct answer. It is formed by the actual converging of ray of light, and that means option 1 is correct, option 2 is correct, and option 4 is correct. But option 3 is wrong because it said it seems to exist. That means it doesn't exist. That means the image is not really existing, and that is not true. That is not true, and that's the answer to that question. Number 39. Which of the following does not cause a reduction? Okay, a reduction of the surface tension of water. Now, when you hear the word surface tension, now which one cannot reduce surface tension? If you have ever seen water before, you place down water and you see that on top of the water there's something like a little film, by which if you know that mosquitoes can walk on water, on that part of water that has the little film. That film is caused by water itself. Okay, that film is like a rubber, but a tiny thin rubber created by the water molecule on the water surface. So if you put sand on it now, the sand will stay on that, and that thing is called surface tension of water, because the water tension, so it can create that film by surface tension. Okay, now which one cannot reduce surface tension? 1, if you wash your clothes with soap, it is going to be clean, because the water can penetrate the clothes particle and remove dirt. But if there is no soap in the water cannot enter the cloth material and remove dirt, because the water will form ball, and that is a function of surface tension. So water can penetrate clothes well without soap. So soap helps to reduce surface tension, and also detergent help, and also alcohol also help to weaken. Now, if you want to wash some clothes and they have stubborn stain, you can put alcohol. Alcohol also help to weaken the water tension, so that the water can easily penetrate the clothes. But grease does not. Grease does not affect water tension at all. If you pour grease, it's like oil, but thick oil. If you pour it into the water, it will not affect the surface tension. It does not have any effect on the surface tension of the water. So the wrong one is grease, and that's the criminal we are looking for. In what range of temperature is the expansion of water anomalous? The word anomalous means abnormal. Now, water, everything expands when they are heated, except water. At 0 degrees Celsius to 4 degrees Celsius, water does not expand. Water rather contracts. So every material on Earth, when you ease them, they expand. But water between 0 to 4, it behaves anomalously, that means abnormally. Between 0 to 4, it contracts. Okay, so the temperature range where water behavior or expansion is anomalous or abnormal is between 0 to 4 degrees Celsius, and that is the answer to that question. You can see it here: ice, warm water when heated, and here is the cold water. So I just use this to explain that. So it happened between 0 degrees Celsius to 4 degrees Celsius, and then from 4 degrees Celsius, the water begins to expand normally like everything in the universe. Between 0 to 4 degrees Celsius, science has said that water does not expand first, it first contracts, and then from 4 degrees Celsius, it begins to expand. And that's the answer for number 40. And that brings us to the end of this video. Don't forget, if you learned something from this video, click on like button. We have more content to show you that will better help you understand physics. Until next time, guys, take care of yourself and bye for now.